Hi students, welcome back to my channel. In this particular video, I'm going to teach you how to draw an isometric diagram from the given orthographic views or orthographic diagrams using AutoCAD software. In this particular diagram, I'm going to teach you to draw isometric diagram without showing the solution at the first instance. If you guys have viewed my previous two videos of isometric diagrams, there I had compared orthographic views, that is your question, and isometric diagram, I mean your solution. I had compared both the things and I have drawn them. I have drawn the solution isometric diagram using AutoCAD. But because I believe that you have gained certain knowledge in isometric views, so I'm going to show only the question and I'm going to draw the solution, your isometric diagram. Now first let us look at the isometric, first look at this now let us first look at the question, that is our orthographic views. This is our question, this is our orthographic views, and from the given these three views, they have actually given us three orthographic views, that is front view and top view, which are mandatory for each and every question, and the other one is left side view. Since left side view is given here, as we are following the first angle projection methods, and the left side view is always drawn on right hand side of the orthographic front view. Now from these given three orthographic views, we have to generate the isometric object. The basic thing in isometric diagrams is, in order to draw an isometric diagram or isometric object, the first thing is we have to get the data from the three views. It is not that we are going to completely rely on one view while drawing one particular view in AutoCAD. We can't rely on only on one view. We have to get the data from the other two views. For example, if I'm drawing a top view, certain data should be obtained from front view or from side view. The same with the other cases also. The best practice in isometric diagram is to start with the front view. In front view, as per the question is concerned, we guys can see three surfaces, namely A, B and C. Guys, I have given these lettering for simplification purpose, in order to teach. In general, when you are practicing by yourself, you try to give a naming or lettering as per your wish. Now in the given front view, I have taken three surfaces, namely A, B and C. Now from the orthographic views, I can't tell you precisely where the surface A is actually located, or surface B is actually located, or surface C is actually located from the front view alone itself. But I can get their actual location, or I can decide from where to start my diagram by comparing front view with the other views also. Sorry. Now I'll compare my front view dimensions with the top view. So see, the front view surface A this is having a length of 20 mm and a height 15 mm, and this particular line length is not given here, and we have to draw it by ourselves. In the same way, surface B is having a length of 20 mm and surface C is having a length of 20 mm, and this particular line length is 50 mm. It was not given here, but we must consider this one as 50 mm. Good. Now can you guys see this particular line, the surface A line, this particular line, the line coming from this point to this point? This particular inclined line is represented in the top view by this line, by this particular line, the line on which my cursor is moving. In the same way, this particular line, the surface line B, this line, the line starting from this particular point to this particular point, that line is represented by this particular line. And the line, the surface line C, this line, the line from this point to this point, this particular line is represented by this particular line in the top view. Now if you guys can clearly observe that the surface line A, and the surface line of A and the surface line of C are in line with each other. Almost they are lying on a same line, whereas the surface line of B is at some distance. That distance was mentioned as 10 mm. So first let us start drawing the front view with the data obtained from front view dimensions as well as from top view dimensions. So now let us get back to the AutoCAD. Yes, here is our AutoCAD software. The first step is, as usual, in order to get rid of those grid lines, we have to press F7 function key. Now type DS, D for drafting, S for settings, hit enter. First go to Object Snap. Make sure that all the options in Object Snap, all the square boxes in the Object Snap window are having tick marks. Make sure that each and every box is having tick marks just by simply clicking on select all option, and also check whether Object Snap tracking on is having tick mark or not, and Object Snap is also having tick mark or not. Just check them once. Now go to Snap and Grid. Go to Snap and Grid. I have seen some of the students are marking a tick mark in this particular box. Remember guys, if you want to carry on with the isometric drawings in polar tracking method, the snap on should not have a tick mark here. We should not have a tick mark at this particular point. Now go to snap type, grid snap. We have to get back to the isometric snap. In order to change from two-dimensional standard view to isometric view, we have to select this particular thing, isometric snap. Now go to polar tracking. The polar tracking, under polar tracking tab, this particular option, that is polar tracking on in brackets F10, this particular option must have a tick mark here. Okay, and then the increment angle. The increment angle in some systems by default it is going to be either 90 degrees or 45 degrees, but it has to be 30 degrees. Select 30 degrees and now click on OK. Now let us change the units. Let us set the units. UNI TS. The command for units is UNI TS. Hit enter. Now the length type has to be decimal. Precision, for this particular problem I'm going to choose 0 precision. And insertion scale, instead of inches let me select millimeters and let me click on OK. Now let us set the limits for our model space, and the command for limits is limits. LIMITS, limits. Hit enter. The lower left corner value is always 0, 0, enter. And the upper right corner, it depends. The upper right corner value depends from diagram to diagram. For this particular diagram I am going to choose values in between 150, 150. Hit enter. And immediately after limits command we have to go for zoom, 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 enter, and sub option all, A, enter. By this way we have set our isometric view space. And now let us start drawing the object. Now let me, at the first instance, let me change the properties, that is line weight. Just for your clarity purposes, let me take a value of 0.35 mm and let me turn on the show/hide line weight option on. And now let me go to home tab, draw panel, and let me click on just give a click on a line command. Now the moment you take a line command, it is asking you to specify the first point. Just give a click here. Now let me go to the diagram once. See, here they had given left side view. Here they had mentioned left side view. So my front view should start in the right hand side direction of the point from where I had clicked. So the positive direction in right hand side direction is 30 degrees and left side is 150 degrees. Okay, now here I'll start from this particular point. From this particular point I'll go in the downward direction for 15 mm, then from there to there 20, again 20, again 20, and back to 50 mm. This height, this particular dimension was not mentioned here, but the length of this particular line is 50 mm. So first in the downward direction, that is in 270 degrees, I have to travel a distance of 15. So type 15 and hit enter. Now move your cursor in the right hand side direction, that is in the positive 30 degrees. Now move your cursor such that you are getting an polar track around 30 degrees. So, and the distance is 20, enter. And again in the 30 degrees direction, again 20, enter. Now again in the 30 degrees direction, 20, enter. Now move your cursor in the vertically upward position, that is in the 90 degrees direction. The moment you get 90 degrees polar track, type 50 and hit enter. Now simply join this endpoint with this endpoint and hit escape key. See, actually we have got a particular surface which includes A and C and B also. So now we have to obtain surface A and surface C just by drawing two simple lines. Now go to line. Now first move your cursor to here. This is 0 point. Now move your cursor steadily on that particular line. You will get a midpoint, and again move your cursor. You will get an end point. That end point is at a distance of 20 mm. Just give a click here and move your cursor in the upward direction. Type any value. Type any value. Say I am typing 50. Type 50 and hit enter. Now hit escape key. See, I want a line which is not crossing this particular line. So I am going to trim this unwanted portion. So the command for trim is trim, trim, enter, hit enter twice. Just give a click here. Hit escape key. So guys, this is our surface named A. Again, now let us generate the surface C now. Take the line command again. Now just move your cursor to this endpoint. That is your 0th point now. And now again move your cursor. You will get a midpoint. Again move your cursor. You will get an indication for endpoint. Just give a click there. And move your line in the upward direction, that is in 90 degrees. Just type some value. I'm typing 50 again. 50 enter. Hit escape. Now again I doesn't want this extended portion, so I'm going to trim it again. trim, enter, enter. I'm going to hit enter twice. Just give a click here and hit escape key. So this is my surface A and this is my surface C. Actually I doesn't want this particular line and this particular line. I'm going to erase it. Just simply select the line and hit the delete key. And I also doesn't want the line in between surface A and surface C. So I'm going to trim this particular portion. And the command for trim is trim and hit enter. Again hit enter twice. Just give a click here. Okay, now we have generated surface A and surface C. Now we are going to generate surface named B. So take a line. Now from this particular point we have to travel in left hand side direction in the positive way, that is 150 degrees. Just give a click here and in the 150 degrees direction, and this particular length is going to be 10 mm. So type 10 and hit enter and hit escape key. See, if you guys can see here, this is your surface B and if it is vertically projected here, and you can see that surface B is having certain distance from surface A and surface C. That particular distance is given as 10 mm. So only I had taken 10 mm over there. Now again take another line, give a click here at this end point. Now again move your cursor in the left hand side direction, that is in the 150 degrees direction. Type 10 and hit enter and join this particular endpoint with this particular endpoint. Hit escape. Okay. Now take copy command. Now we are going to take a command called copy. COPY, copy. Hit enter. Now it is asking you to select the object. I want to copy this particular line. So select that object. After selecting of this particular line, hit enter. Now after hitting enter, it is asking you to specify the base point. I'm going to select this particular point as my base point. Just give a click here. Selection of base point means just giving a click at one particular point. Okay, this is the particular point. Just selection of base point means just clicking at a point from where we have to move the object. This is my point. Just give a click there and move to this particular endpoint. Give a click and hit escape key. In order to come out of the copy command, just hit escape key. Now take another line, go to this endpoint, give a click there and move your cursor up to this endpoint and just give a click and hit escape key. That's it. We have generated surface I. If you can see at the question, this particular surface is called I. The surface which we have generated here is known as surface named I. Now take another line, give a click here, give a click at the endpoint here. Now move your cursor in the right hand side reverse direction, that is in 210 degrees. As we all know, the distance between this particular endpoint and this endpoint is 20 mm. So just move your cursor into 210 degrees direction and type 20 and hit enter and hit escape key. Okay, now we have to trim this unwanted portion of the line here. So the command for trim is trim trim. Enter, enter. Just give a click here and hit escape key. So we have generated in totally 4 surfaces, that is surface A, surface C, surface B and surface I. This particular surface I is visible only in the left hand side view that was given in the question. Now let us start drawing our before start drawing our side view, let us go and check the data. See, in the side view we are having we are able to see totally 5 named surfaces, that is surface number G, surface H, surface F, surface I and surface D. Now first let us look at surface F. The surface F is having a dimension of 15 mm and 15 mm, whereas surface H is having a dimension of 15 mm and 21 mm. And the surface G is also having the same dimension of the surface F, that is 15 mm length and 15 mm height. Now let us check whether the position of surface G, H, F, I and D. See, with the front view, from front view we are unable to get any data related to all these 5 surfaces. So now let us check the top view. In top view, if you can see this line, this particular line, the line where my cursor is moving, it represents the surface line of G. Whereas this particular line, it represents the surface line of H. And this particular line, the line where my cursor is moving, this particular line represents the surface line of F. And in the same way, like the surface A, B and C, the surface H is not inline, whereas surface G and F are inline with each other, whereas surface line H is not inline, it is at a distance of 10 mm. Okay, now let us draw the side view of surface G, surface H and the surface F. As we can say, the surface I is already generated in the front view itself. Now let us get back to the AutoCAD. Take a line command, just give a click here. Now in the left hand side direction, that is in the positive direction, because it is in left hand side positive direction, the angle has to be 150 degrees. In 150 degrees I have to travel at a distance of 15 mm. That is for surface F. Hit enter. Again in the 150 degrees direction, again another 15 mm. This is for surface H. Again in the 150 degrees direction, again 15 mm. This is for surface named G. Hit enter. Now in the upward direction, that is in 90 degrees, the height is also 15 mm. 15, enter. Now again, now we have to move our cursor in the left hand side reverse direction, that is in 330 degrees. That is in 330 degrees. We have to travel a distance of 15, enter. Again in 330 degrees, 15, enter. Again in 330 degrees, 15, enter and hit escape key. Okay, now let us generate surface G and F first. I'm going to generate surface G and surface F first. Later on I will generate the surface H. So for generating surface G, take a line, move your cursor, you will get an indication called endpoint, that is your 0th point. Now move your cursor on that line, just don't give a click anywhere, and you will get an indication called midpoint. Again move your cursor, now you will get an indication called carefully look for an indication called endpoint. Now give a click, move your cursor in the upward direction, vertically upward direction, that is in 90 degrees, type 15 and hit enter, hit escape key. Again take line command. Now move your cursor towards this particular endpoint and consider this point as your 0th point now, and now move your cursor along that particular line and you will get an indication called midpoint. Again move your cursor in that particular on that particular line only, you will get an indication called endpoint. Just give a click there and move your cursor in the vertically upward direction, that is in 90 degrees, type 15 and hit enter, hit escape key. In this way we have generated surface G. The place where my cursor is located is called as surface G, and the place where now my cursor is being located is called as surface F. Now let us generate the surface H. Now first let us look at the diagram. The surface H, in the left side view they had given only one particular dimension, that is 21 mm and 15 mm. But when we compare this particular view, I mean the left side view with the top view, we know that surface H is at a distance of 10 mm when compared with the surface G lines and the surface F lines. So let me get back to AutoCAD. So let me delete this line and this line. Simply select both those lines and hit delete key. I mean press delete key. Now take a line command. Move your cursor towards this particular endpoint. Just give a click. And now move your cursor in the right hand side direction, that is in 30 degrees direction, and type 10 and hit enter, hit escape key. Now move your cursor in the vertically upward direction, that is in 90 degrees. From the left side view we know that the height of surface H is 21 mm, so type 21 and hit enter, and now hit escape key. Take line command, join this particular line with this particular endpoint, hit escape. The same way has to be repeated here also. Take another line, give a click here. Now move your cursor in the 30 degrees direction. Just move your cursor in the 30 degrees direction, type 10, hit enter, and now move your cursor in the vertically upward direction, that is in 90 degrees, type 21 and hit enter. Now join this particular endpoint with this particular endpoint and hit escape key. Now take a line, join this endpoint with this endpoint, hit escape. Now take another line, now click at this particular endpoint and at this endpoints, hit escape key. Now we have generated surface H also. Now guys, if we consider this particular object as a solid object, as a three-dimensional solid object, the internal elements will not be visible. So that is the only reason there are certain dashed lines in your orthographic views, which means that these particular elements are not visible when viewed from one particular view only. So what I am going to do is I am going to delete the internal elements. So this line and this line has to be deleted. Just simply select them by giving a click on them and hit delete key. And this particular line will be visible up to some portion, and majority of the portion will not be visible if this is to be considered as an three-dimensional object. So what I'll do is I'm going to trim the unwanted portion there. So trim, 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 and hit enter twice and just give a click here and hit escape key. That's it. So in this way we have generated surface F sorry, in this way we have created surface F, surface H and surface G, and with one single step we can generate the surface D also, and with one single step we can generate the surface D also. I'm going to show that to you guys now. See, the line, this particular line, the inclined line which is joining the surface A and the surface C is also joining the surface the other portion of the diagram. So what I'm going to do is I will draw a line. First let me take the line and I will draw a line from this point to this point and I'll hit escape key. Okay, I'm repeating the process again. I'm taking a line command and I'm going to draw it from this endpoint to this endpoint and hit escape key. Now what I'll do is I'll copy this particular line, or I'll move this particular line from this endpoint to this endpoint. So the command for move is move, move. Hit enter. Now it is asking me to select the object to move. Move your cursor towards this particular portion of the line. Just give a click and select it. After selection, hit enter. Now it is asking you to specify the base point. Just give a click at this particular endpoint as your, consider this particular endpoint as your base point by giving a click there. Give a click, move your cursor up to the endpoint of surface G. Give a click, hit escape. That's it. Now simple thing is take a line, give a click at this endpoint and at this particular endpoint hit escape. I have drawn this particular line just to demonstrate that we can draw a surface D in a single step. Actually there is no need of this line because we have to go with the dimensions. So in this way we have generated almost the surface D also. Okay, for your understanding purpose I would like to repeat the process again. I'm deleting this line. In order to generate the surface D, what I'm going to do is I'm taking a line command. I'll give a click at this particular point and I'm going to give a click at this particular point and I'm going to hit escape key. Now I'll go for move command, move, hit enter. Now select this particular line at this particular portion only. Give a click. After selection of object, hit enter. Now it is asking you to select the base point. Select this point as your base point. Just give a click. Move your cursor up to this surface G endpoint. And then give a click when it indicates endpoint. Give a click. That's it. Okay. In this way we can generate the surface D also. Now let us complete the diagram, isometric diagram, by having look at the top view. So we can complete the other surface, the remaining surface, that is surface E. Let me check the portion here. Yes. Now let me look at the this particular thing and the side view. Let us look at the side view. The distance from this point to this point is 15 and the distance from this point to this point is also 15, and the length, the height from here to here, the depth is 10, which is mentioned in the front view. And if you look at the top view for surface E, it is having a slot distance of 17 mm. It is having a slot distance of 17 mm and the depth of 10 mm, which is mentioned here. The depth of the surface E is 10 mm and the slot distance is 17 mm. Now let us get back to the AutoCAD. Now take a line, just give a click here. Now move in the left hand side direction, that is in 150 degrees. Make sure you are getting the track of 150 degrees. Type 15, enter. Again move your cursor in the 150 degrees. Again type 15 and hit enter. Again move your cursor in the 150 degrees. Type 15 and hit enter. Now hit escape key. See guys, we can directly type 45, but if we type like that we are not going to get specific endpoints. Again we have to redraw them. So for that purpose only I'm segregating the dimension as 15, 15 and 15 as given in the orthographic view. Now take your line, take a line. Now move to this particular endpoint. Now consider this as your 0 point. Just don't give any click, just consider it as your 0 point. And now move your cursor along that line and you will get an indication called midpoint. Now again move your cursor along that line. You will get an indication called endpoint. Just give a click there. And now move your cursor in the downward direction, that is in 270 degrees direction. And make sure that you are having the polar track of 270 degrees. Now the depth as given in the front view. When we had compared the left side view with front view, the depth was given as 10 mm. So type 10, hit enter. Again, now from this point, now move your cursor in the right hand side reverse direction, that is in 210 degrees. Okay, make sure that you are having a polar track of 210 degrees. In this particular direction, the slot distance was mentioned as 21 in your top view. So now move your cursor in the 210 degrees, type 21 and hit enter. Now hit escape. The same thing has to be done from the other end also. Now take a line. Now move your cursor to this particular point and consider that one as your 0th point. Now move your cursor along that line. You will get an indication called midpoint. Again move your cursor in that particular line, on that particular line only. You will get an indication for endpoint. Give a click. Move your cursor in the 270 degrees direction, that is in the vertically downward direction, and type 10 and hit enter. Now move your cursor in the right hand side reverse direction, that is in 210 degrees. Type 21 and hit enter. Join that line with this one and hit escape. Okay. Now let me check the accuracy of this particular line. Let me take a line from this point in the 210 degrees. Okay, it is correct. No need. Now what we have to do is we have to take a line, select this end point, join up to here, hit escape key, and take another line, click at this end point and join with this end point, hit escape key. Now select this particular line and erase it just by selecting and hitting delete key. Now take another line, join this end point with this end point just by giving 2 simple clicks at those endpoints, hit escape. Now as this is a solid object, as we are considering this one to be a solid object, I have to remove a certain portion of this particular line. So the command for that is trim, T-R-I-M, trim, and hit enter twice. Just select that particular portion, hit escape in order to come out of the trim command. So this is how we have to do the isometric diagram. And if we carefully observe, this particular line and this particular line are also not visible if we consider that this object as a solid object. So delete them, select them and delete them. So this is how we have to generate an isometric object from the given orthographic views. And now let us give dimensioning for this particular diagram. So as we are considering all the elements as inclined lines, so I'm going with aligned dimension, that is from home tab, annotation panel. Just give a click here. We'll get an option called aligned. Just select it. Before going for that, let me change the property back to by layer. Go to aligned. Just give a click at this particular point and this particular point. Drag it and just place it. Since your dimension is not visible, we have to change those things by going into the dimension style manager, and the command for activating dimension style manager window is D for dimension, D enter. Go to modify. First go to primary units, check whether the unit format is decimal or not, and the precision should be 0. So change it back to 0 because it is earlier it is 0.3 zeros. Now go to fit, and under the preview window there is an option called use overall scale off, and the value is 1. Because I want my dimensions to be bigger ones, I want them to be appear as a bigger ones, so I'm going to increase the value, increase the default value. I'll increase it to, let me say, 12. Now let me go to text, and the text alignment for isometric chapters, it should be with as aligned with the dimension line, and the text placement, vertical text placement should be above. Now let me click on OK and then let me close it. See, I hope the dimensions are visible now. Now again, let me go to aligned dimension. Let me give a click at this particular point and this point. Weltna. వెళ్తాను ఇది రికార్డింగ్ అయిపోగానే సరే సరే now this particular thing, just drag it and give a click at this particular node or intersection. For some systems it might be showing as intersection, for some it might be showing as node. Just give a click so that both the dimensions are in line with each other. Again take another dimension, click on aligned, give a click at this particular point, be careful in choosing them, give a click at this particular point. Now again drag it and just place it here. Okay, now I would like to change the oblique angle of these 3 dimensions. See, I am repeating again, the extension lines of all these 3 dimension lines should be in line with this particular line or this particular line. Both these lines are vertical lines. That means the oblique angle is going to be 90 degrees. In order to edit or in order to change the oblique angle, we have to go to the dimension edit command. That is DED. D for dimension, ED for edit. Hit enter. And now choose the sub option oblique, O enter. The moment you type O and hit enter, it is asking you to select the objects. Now select all these 3 dimensions, hit enter. The moment we hit enter after selection of dimensions, it is asking you to mention the oblique angle, and the oblique angle is 90 degrees. So type 90 and hit enter. So we got the dimensions for front view. Now let me give dimensions for the left side view. In the same way, again get back to aligned. Now give a click here, another click here, just drag it and give a click. Again get back to aligned command, give a click here, another click here, drag it and place it up to this point. Now again take another aligned command, give a click here, another click, drag it and just place it. Now we have to change the oblique angle for these things also. Guys, if you find the extension lines of these dimensions also should be in line with this particular line and this particular line. So the angle for those lines is 90 degrees. So let us get back to the dimension edit command, DED. Hit enter, oblique O enter. Select the dimensions by giving a click. After selection of dimensions, hit enter. Now it is asking you to mention the oblique angle, and the oblique angle again is 90 degrees. Hit enter. Okay, now let us give dimension for the top views or the other views. Now take dimension aligned, give a click here and another click here, drag it and just place it. Okay, now this particular this particular extension lines of this particular dimension should be in line with this particular line. This line is on right hand side, that means it is having an angle of 30 degrees. So the dimension oblique angle is also 30 degrees. The command for dimension edit is DED enter, oblique O enter. Select this particular dimension, hit enter, and it will ask you for angle type 30 and hit enter. Okay, in the same way, now let me give dimension for this particular line, this particular line. Okay, dimension aligned, give a click here, another click here, just move it and give a click. Now instead of selecting dimension aligned each and every time, what I'll do is now I'll go to a tab called annotate tab. Okay, now after giving the dimension, go to annotate tab, and there you can see an option called continue. Under dimensions panel you can see an option called continue. Just give a click there. Now you will get dimension automatically. Give a click here, give a click here, hit escape. Now automatically they will be in line with each other. Now again type DED enter, oblique O enter, select the dimensions, hit enter. Now these should also be at an angle of 30 degrees. So type 30, hit enter. Okay, you can also give 90 degrees for these extension lines, but this is much better rather than having dimensions being projected above the diagram. Okay, in the same way we can give dimensions for the other elements also. See, for example, this particular line, let me select dimension aligned. Okay, now give a click at this end point, and at this end point drag your cursor and just place it. Go to dimension edit, DED enter, oblique O enter, select this particular dimension, hit enter, and this one should be with this angle. So just give a click here and another click here, you will get the dimensions. Or you can also rotate it in the 150 degree direction or 30 degrees direction also. Okay, guys, this is how we have to I hope you understood the process of summarizing your orthographic view or imagining your orthographic views into isometric diagrams, and this is the process of dimensioning also. Thank you guys.